All right, so on the solutions, like I highlighted in the blue, anything like formula-wise you need to know, okay? At the top, this is what I just told you. There's 35 multiple choice, 7 graphs. The multiple choice are worth 2 points each, and the graphs are 4 or 5 points. I think there's one that's 5 point. Yeah. And then again, you'll start with the calculator. So we just talked about that briefly. The ones that are calculator based, I think I highlighted, right? These are your calculator questions, okay? So you'll get like your interest problem where you need to, and I actually put on there like these two, you just need to know which one to use. I give you both those formulas. If it's compounded continuously, you're using per. If it's compounded a certain amount of times a year, like 54 is, then you would do that first formula, the P times 1 plus R over N to the NT. Then there's a question like they're just like this, where you'd have to factor and then use your ln to solve. You're going to get a word problem, okay, right triangle trig, and then this either finding the sine, cosine, tangent, secant, or cosecant of a specific angle. Pay attention to your mode there. Or the reverse, where you're finding the inverse. So if it's got the -1, you're finding your inverse. That's where you'll start, because those will be the first questions are your calculator ones. And then it will go into the rest of it. So because we're going to start there, like I'm going to start there. Any questions on those? Okay. Then goes back to the beginning, I would say. All right, so now any questions on these? So this is midpoint, the graph, like that's a graph of a line, but it could be part of your graphs at the end. Domain, your composite functions, your multiplying, your dividing. These will not all be built into one question, but you could get any of those. You might get F times G, you might get F of G, that kind of stuff. You might get a question on domain there. Then came your inverse functions, your center and radius of your circle given an equation, and your i's. Like this obviously goes way back a little bit, where every time you get the I squared, you're going to replace it with -1. Question on any of those? Okay, this is the work for whatever the composite one. All right, questions on page 2. Now we're getting into rationalizing with your I. And then the quadratic stuff. So again, I highlight this is in blue because that's something you need to know. Okay, vertex is -b over 2a. That would help you with your minimum or your maximum. You need to know your leading coefficient test, the rise and fall. So that's what this is. If the highest exponent is even and positive for the coefficient, they both point up. If it's even and negative, they both point down. So the wording is rises left, rises right, or falls left, falls right. That's multiple choice. And then if it's odd and positive, then it falls left, rises right. And if it's negative and odd, it rises left, falls right. You're going to get questions on zeros and multiplicity of zeros. So remember, if you're going to solve these, if the number occurs an even amount of times, what happens? If the multiplicity is even. Other way around, it bounces. It bounces off at that point. If it's an odd multiplicity, it crosses through. So, for example, number 14, 0 occurs twice. So that would have it bounce. Or the wording actually says touches and turns around. It means the same thing, bounce and touches, turns around. Whereas -√5 occurs once, so it crosses through. Positive √5 occurs once, it crosses through. And positive 9 occurs once, it crosses through. We're good on those? If I get to a topic and you know you need extra practice, can you say something, please? Because those are the ones that I'll make sure I get some extra practice when I see you tomorrow. Okay. Then comes long division and synthetic division. There's literally a question on each of those. Then there's using synthetic division for like 17, where it says one of the zeros is this. You put that number on the outside. you reduce it a degree, and then you find the remaining zeros by factoring. Do that one? Or go more? You want me to do that one?
Or yeah, both.
Okay. So 17. When you're given 1, so this kind of like, you don't have to do the plus and minus first and last and try them. You'd be here forever. So I'm going to give you 1. So this one says that 5 is a 0. So 5's going to go on the outside. And then I list my coefficients. It would be 3, negative 34, 81, and 70. I bring down the 3. I multiply times 5. I put it in the next column. I add it. I multiply by 5. I put it in the next column. I add it. I multiply by 5. I put it in the next column. I add it. Regular synthetic might have a remainder, but if it tells you it's a factor, that remainder should be 0. So then from there, I take all the coefficients that are left. This is my remainder. The first one gets nothing. The second one gets an x. The third one gets an x squared, and it would keep going up from there. So I get 3x squared minus 19x minus 14. And then I would factor that. So I multiply first times last. Negative 14 times 3. Negative 42. I look for the factors of negative 42. That sum to negative 19, which is, what did I put? Negative 21 and negative 2. And positive 2. So I get 3x minus 3x squared minus 21x plus 2x minus 14. And then I factor by grouping. Take out a 3x, x minus 7, take out a 2, x minus 7, and there's my 2 remaining factors. Because it says solve, I'm going to take to the next step and split and solve those. And I get 7, negative 2/3, and the 5 that was originally given to you. So that should be part of all those factors. That one's multiple choice too, so like, look at your answers and work backwards if you had to. All right, now we get into the vertical asymptotes, the horizontal asymptotes. So this was like 2, 5, 2, 6, 2, 7. Questions on any of those? I would definitely review. Obviously, the vertical asymptote comes from your denominator, but make sure you review your horizontal asymptotes, those 3 cases. You're looking at the exponents. If they're the same, it's the leading coefficient. If the one in the top is bigger, there is no horizontal asymptote. And if the one in the top is less than, then it's y equals 0. Which is the case, like, God bless you, 19, they're the same. So it's y equals 2 because it's leading coefficient 1. All right, then comes your graphs. So these are all open-ended at the end of your test. Yeah. All right, questions on any of these graphs? So this is the graph of the exponential. You literally could plot your points. And then the graph of the log. So my advice for the logs is switch your x and y. Or not switch your x and y, but solve for, put it into exponential. All right, so again, for logs, I would convert it to exponential and then plug in for the y and get your graph. Those are at the end. Then kind of this goes back. So back to multiple choice for this log stuff. Questions on simplifying or solving, all this stuff would be without a calculator, this stuff. So like stuff where you have to use your LNs, that's with a calculator. This stuff is all without. Good? Yes? All right, now you're back up to the 1-to-1. So you want to change it so it has the same base. For 29 and 30, you're condensing and then solving. Well, for 29, condensing and solving. 30, it's the 1-to-1 property. That was all chapter 3. And then here we just started chapter 4. That was our trig. So graphing a line in standard position, whether it's positive, negative, in degrees, or radians. Finding your coterminal angles. So remember, coterminal is plus and minus 360 or plus and minus 2 pi if it's in radians. point P on the circle. This is where you would actually like locate your, either draw your triangle, or if it's secant, we're gonna use the sign and flip it, because your cosine is your x, your sine is your y, your tan is your y over x. Like, hopefully we've done these so many times since then that that's pretty stuck in your brain. Questions on those? Questions on reference angles? The inverse tangents. So remember, with the inverse, so all the negative ones, we restrict the domain on this guy. Tangent, you're going to use, tangent and sine, you're going to use the right side, but from negative pi over 2 to positive pi over 2. And cosine, you're going to use the first and second quadrant from 0 to pi. So I would say maybe when you get your unit circle on the day of the test, mark and label those and add on your tangents. Okay, then came coordinate point. So here you're making a triangle. I would say to make sure that you review your Pythagorean triples to make it easier on yourself for that stuff. You obviously, they won't all be triples, but they could be. Here's our sum and difference. So you're going to get a sum or a difference of sine, cosine, tangent. So remember that pattern. That's actually on the reference sheet, like I gave you the sum and difference formulas. And then that's for both of these. That one you're working backwards. And then comes the other graphs. So these are going to be all based on transformations. Remember, if there's something on the front, so it's plus or minus at the front, A, and then whatever the expression is. So let's just say it's x plus or minus a number squared plus or minus a number. What happens if the negative's on the front? Go ahead. So positive would be a regular parabola, negative would be upside down. What happens if there's a number bigger than 1 in front of it? What happens to 10x squared? What kind of stretch is that? It's a vertical stretch. Vertical stretch. It makes it taller. If it was a fraction, so if it's in between 0 and 1, it's a vertical shrink or compression. What happens when you add or subtract something inside the parentheses? Good. So if it's positive, it goes where? Good. And if it's negative, to the right. Good. And then the last number, what happens? Vertical shift. Positive. Good. Up. Negative. Down. And then if we had a negative, like if the negative was underneath the radical here, that actually points it left instead of right. So where my normal radical goes to the right, if it's a negative x, or negative x underneath the root, it would point to the left. If it was a negative on the front, it's upside down. You get 3 graphs transformed. It could be squareds, it could be parabolas, it could be square roots, it could be absolute values, it could be cubic. Like, you want to make sure you would be able to transform all of those kinds of graphs. And then there's the graph of the exponential, the graph of the log, and then the trig function graphs. So you're either going to get a secant or a cosecant, and then you're either going to get a tangent or a cotangent, which is all this stuff. So this, realize you could also get a secant. And this, realize you could also get a cotangent. Just be prepared for those things. And then your identities at the bottom, I'm giving you your reference sheet, so hopefully that helps you with that one. And then here's your double and half angle. So you got your double angle here. This is the stuff we just finished this week. And then your half angle here. It's not going to ask for all 3 of them like it asked for all 3 of them here, just like the quiz. It will ask you for one of those 3. But just make sure you know how to do those 2 things. Like I'm not doing the one where we did the reverse question. But you are going to get one triangle where you have to find the double. and then one angle where you have to find the half. General questions. What do you need extra practice on? Logs, like the solving equations of logs, the graphs of logs, both? Solving? With the calc or without? And Hayden, what did you say? The
long division rules.
Okay. If I give you solve given one root, right? That's it. That's all you need from me, and you're gonna get A's.
Yeah.
Mm-hmm. Mm-hmm.